So we're going to be talking about software testing for EESSI. And of course, if you have a single software stack and you don't have that many users and you have a small group of people, software testing tends to be sort of the last thing you get to, right? Because if you don't have the manpower, what are you going to do? But if you have a lot of users, and potentially the EESSI stack will have a lot of users, we need to make sure it works properly, right? Otherwise, a lot of people will suffer. So just providing the software installations is not sufficient. You really need to make sure they work. There we go. So, well, of course, that brings the question, what exactly should we test, right? And how should we test this? Where should we test this? When should we test this? A lot of questions, and I don't think we have a definitive solution here yet, so it's definitely something that's up for discussion, but we have some ideas. First of all, there's of course the compatibility layer, and I think that's, compared to the software layer, the compatibility layer is relatively easy, right? It's mostly basic executables, so it's also mostly basic tests, just checking, is the executable there? Does it start? Can you run a -- version? And then usually it's already okay. And we have some tests there already. They also work with Reframe, the framework that we'll also use for software layer. And I'll get back to Reframe later on. You can have a look if you're curious, see what's there for the compatibility layer. They're quite easy to read because they're quite basic. But for the software layer, things are a lot more complicated. So what do you want to test in the software layer? We kind of distinguish 5 different things. We said, well, there's something like smoke testing, just, if it's completely blatantly broken or missing, or, those are the very basic tests. And already EESSI Build does some of these tests, right? It does a sanity check to see, hey, are the executables that I expect, are they there? Sometimes there's a sanity check command and it runs a -- version already. So those tend to be already reasonably well covered. Then there's functional testing, a quick test with a limited amount of resources, just to see, do I get the right answer, the answer that I expect? If I run, I don't know, some kind of TensorFlow training, and I expect a final result from that training, do I get that number? Then, of course, there's also performance testing, right? Maybe it gives you the right number, but not in the right time, because whatever, your system is not performing correctly, or something is wrong in the software stack, right? There's integration testing. So sure, it's nice that this works on one system, but does it work on all of the systems where it should work? And finally, there's monitoring, just to see, if it had a certain performance yesterday, does it still have that same performance today, or did something change? And that, of course, is something we want to do, especially if we need to do security updates in the compatibility layer. Really want to make sure, does it still work? Does it still perform the same? Does it have a performance impact, whatever we did? And basically, we want to wrap all of that in a test suite, the EESSI test suite. So how do we do the testing? Well, we've decided we want to use Reframe. Reframe has been designed for testing HPC software. It can do things like interact with your batch scheduler. It can also run tests on the local host, so it doesn't need to have a batch scheduler. But at least it knows how to talk to one and submit multi-node jobs and check the results from those. It supports both functionality and performance testing. So if you know what the expected performance is, you can basically program that in your Reframe test and tell it, okay, you know what, you need to get this number from the output file and it needs to match some other number, some reference within a certain margin. And Reframe will tell you at the end of the test, like if you met that margin. And then the other 2 questions, like when and where to test. I guess smoke testing is something we can very easily do, right? It doesn't cost much. Probably we'll do that on the build node, right? And that's probably already part of EESSI Build. Need to make sure that whatever we build with EESSI Build actually has those sanity tests in there. But that's the easiest way to do it. For functionality testing, we can do some things on the build node, right? You could do a single node run of some software application. If it's a very lightweight, like a lightweight input, then probably you can do this on the build node in a reasonable time. But also there will be a stage where you've already deployed it to some development environment. I think the solution that Bart Alderman showed us on Wednesday, like having a development CVMFS environment, that could be a very nice way to go, because then you can actually also run it on a larger cluster. You can run it on a cluster in the cloud, whatever, and really already do some multi-node testing, see if you still get the right answer there. And also performance testing is basically the same type of thing, right? You need to have this already in some kind of CVMFS environment if you want to do the multi-node tests. So for integration testing, I guess it's nice if we can make the test suite so easy to run that a lot of people can just do it on their own systems, right? If we want to use it as our main software environment at Surf, we'll definitely want to also run the test suite at Surf regularly on our own system just to make sure that it still works. And we should make that as easy as possible. Also for the individual end user, like if you're on a laptop and you just want to know, like, hey, did I mount everything correctly? Does it work on my machine? It should be easy to run the test suite. So we have to take that into account when we design the test suite. And finally, there's monitoring. So there we'll probably have some fixed test infrastructure. Again, it could be that certain parties contribute cycles to that. Like, okay, we'll just run this test regularly at Surf and we'll actually push back the results to some monitoring tool. We have to still see how we set that up, but I can imagine we set up something like that. So you've seen this slide yesterday already in the talk about the bot. And you might have noticed there's two places where we have the reframe testing. So part of that is the build nodes, right? So those are more the lightweight, single node tests. And then at the bottom right, those would be the tests where you really test functionality and performance at scale. So one problem, of course, is that these tests need to be portable, right? You don't know in advance which system they're going to be run on. So it needs to do something sensible, whether you're on a laptop or whether you're on an HPC system, or wherever you are. And that's actually not an easy thing. So it's probably going to be one of the hardest things we have to solve in terms of working with Reframe. Because Reframe was not originally designed for this, right? Reframe was designed to for institutes to just write their own tests, test their own infrastructure, and then you know what system you're going to run it on. Again, we need to make sure we have a low bar to entry. So the end user, he will need to let us know a little bit about his or her system, but it should be as limited as possible, and it should be located in one configuration file, ideally, so that tell the user, okay, this is how you set up the configuration file, and then you can run the whole test suite. That also means that the test logic should really be decoupled from system-specific details, which is quite difficult, right? So in Reframe, you might, like traditionally, you might say, okay, this test should run with, I don't know, 12 MPI ranks and 3 threads per rank or something like that. That is very system-specific because it fits a certain node size. And if your node size is different, that's not going to work very well. So probably in our test, we don't specify a hard number of threads, but we would like to specify something like, okay, we'll schedule, 1 thread per core, or we'll schedule 1 MPI rank per socket, and then use the rest of the core for threading, etc. Something generic like that. The one advantage that we do have is that the software stack is the same on all systems, right? Because that's the easy software stack. So that already makes it a little bit easier. At least we know what the module names are going to look like and what we're going to have available in terms of software. There were a couple of specific features already added in Reframe because we've been talking to the Reframe developers a lot about how to make these more generic tests. And they're very open to this discussion and to actually also put new features in Reframe to support this. One of the things they're also doing is they're building their own test library, which is kind of a base layer. And then as an institute, you can build your own test on top of that. So for example, they provide a GROMACS test, which basically specifies which test case to run, so which input file to use, which sanity pattern to check in the output file, like, okay, if the run finished successfully, this pattern should be in the output file, and how to extract the performance number from that output file. Those kind of things are already in that basic test. The system-specific things would then be in a test that derives from this class. So that is something that as an end institute, you would then write yourself, and you would say, okay, I want to run this with, again, 12 ranks, so many threads, whatever you want to do. For us, even that system-specific thing has to be generic, right? So for us, it's a little bit more difficult, but we could still derive from those tests because, well, why would we maintain that part ourselves if the reframe community can do it for us, and if we can also contribute back to the reframe community? So that could be a nice synergy there. As I already mentioned, the standard reframe was not really designed for portability, right? It was mostly for a single institute just testing their own hardware. Just to show you an example of that, this is one of the tests that we developed ourselves. It's a GROMAX test. In case you've never seen reframe before, it's class-based. It's sort of readable. A reasonable balance between what we can fit on the screen and readability. So basically, it's based on classes, right? And if you only want to run something and not compile something, then run something, you derive from a reframe class called the run-only regression test. And it has a couple of stages, right? There's an initialization stage, there's a setup stage. In a compile test, there's also a compile stage, then a run stage, and then a stage where it checks the sanity output and the performance number. So it contains things like, okay, which executable should we run? What are the executable arguments? Should we run anything right before we start the executable? What is going to be the time limit of this job? So if it needs to talk to a scheduler, how long does the test typically take? Of course, on your own system, you kind of know that really well, right? You know this test case is going to take 5 minutes, so if I schedule 10, I'm good. And then there's this stuff like the performance pattern, right? So it needs to extract some kind of, with a regular expression, some kind of part of the output file, store that in a number, and compare it to a reference. Now, this is the base class, and then we've made an implementation to run on CPU nodes and on GPU nodes. I will scroll to the one about the GPUs. So there, you know, reframe, you have this thing called valid systems. You know, this is a test that requires GPUs. We know which partitions in the system contain GPUs, and we just specify, okay, only run this test on these partitions, right? This is, of course, the problem that we will have in designing an easy test suite. We do not know in advance which partition names people are going to use in their configuration file, which ones are going to contain GPUs. So the only thing that we can do at this point in time, or the thing that we did at this point in time, is just say any system is valid, right? But that's a problem, because then if a partition does not contain a GPU, still launch a GPU test. So you have to do something there to make sure that that test gets skipped. All right, back to the slides. One of the nice things about having a test suite like this is that it also opens up the ability to collaborate with experts on these software packages, right? Because it's also beneficial for them. If they have a test suite that is regularly run on a big variation of HPC systems, that is very valuable input for them. Like, they know whether it works or not, and they can see if it has problems on certain architectures, for example. That is something that, you know, could be quite challenging for developers themselves to figure out if they have access to only a limited set of architectures. So we hope that they are willing to also invest in a collaboration where they can help us design the right tests for their software, because, you know, they know their software best. They know what could potentially break and what would be a good test case to check their software. On the other side, a different application is that developers themselves could use this in CI, right? We already discussed this a little bit on Wednesday as well, to check with different compilers, different dependencies, etc. Oh, yeah. There we go. Yeah. So what is the current status? Well, we've been struggling a lot in making a generic test, right? Because it was not so easy to do this in reframe. So we played a lot with how can we make it as generic as possible. So it's not like we have a big test suite now. We have 2 pull requests, one for GROMAX and one for TensorFlow, which also uses Horovod for multi-node stuff. And there is the test for the compatibility layer. So that's sort of the current status now. Yeah, so what do we want to do in the future? Well, the config file right now, if an end user would want to run these tests, they would still need to write the config file themselves for reframe. There is some support in Reframe to automatically detect, what kind of processor do you have, how many cores do you have, etc. It doesn't extend yet to, for example, accelerated devices. So those you will still need to by hand, but it's slowly moving in that direction. So that is something that we would like to keep collaborating on with the Reframe developers to see, can we automate the generation of this configuration file even more, ideally to the point where the end user doesn't even need to manually specify anything at all. There's also some new features in Reframe that got added also because of discussion with us. So for example, these valid systems, we asked like, well, could we just specify features that a certain system should have to be valid? For example, it should have GPUs, right? And then people would specify in their configuration file, this partition has the feature GPU. Would still need to agree on a set of labels, right? Because these are just text labels. So we agree that, okay, in this test suite, the GPU label means you have a GPU of whatever type. And then probably at some point we'll discover, oh, but maybe we need to make a distinction between AMD and NVIDIA, etc. So we need to figure out what labels make sense, and we need to agree on. Performance testing is still an open challenge. So for now, we've just postponed that and said, let's only check sanity. The trouble with performance is that it's very hard to predict beforehand. You run on any random system, what is your GROMAX performance on a certain test case going to be? Depends on a lot of factors, right? It depends on the type of cores you have. It depends on the interconnect. If it's a multi-node job, that's not so easy to predict. So yeah, where in the traditional Reframe use case, you would just hard code that for your own system because you've run it, 10 times and you know what the performance should be. In generic use case, that's a lot harder. And then one of the more policy-based questions is, should software always come with a test? So once we're getting to this point where we're accepting community contributions, do we always roll out software even if it doesn't have a test? Do we require the community to write a test before we deploy it in the EESSI environment? How are we going to handle that? Probably if we require a test before we roll anything out, it's going to be a long cycle, right? Which might be annoying to somebody who says, yeah, I need this piece of software as soon as possible. So I can imagine that we'll be flexible in this, and that maybe we say, let's focus on reporting which software has been tested, right? So then at least we're transparent about, okay, this software has been tested, this software has not been tested. And that would at least keep the cycle pretty quick in deploying new software. All right, so let me see, what is the time? 10 minutes left. I think I'm going to do this as a demo, but if you want, you can try to follow this and do it yourself as well. If you have access to the CITC cluster, you can log in and run an interactive job. Start that as well. Yeah. Computer says no. That's fun with the demo effect. No.
Hi, Casper.
Hey, yeah.
Just whilst you're kind of hacking on stuff, if you've got a moment, some dead air filling. What are the chances that, because of course software has dependencies, those dependencies can be distributed.
Oh yeah.
What are the chances that the testing framework would end up growing exponentially against the software stack rather than linearly?
Because of the dependencies, you mean?
Yeah, exactly.
Well, it would still be linear. Dependencies count as well.
Yeah, but you've got, for instance, X with Y, X with Z, X with Y, X with Y with Z.
True. So, I mean, this could be another reason why we say, okay, we don't test everything, right? We just test a subset. I don't know. I don't know if you would need to adjust the tests. Like, if you don't need to adjust the tests, then maybe you could say, okay, I run the full-scale tests for one combination, right? The single node jobs for all of the combinations. That could be a way to.
Probably imagine a scenario where we have groups of tests, right? The ones that we run, as said, are our test suite, but then a developer might be interested in this idea of combinations of this and that with those. And we could ship those tests, but we might necessarily run them all, right? So we might choose a set that's we might go individual applications, right? So not GrowMax, but not GrowMax with QMC pack, right? We're not interested in that, for example, right? But probably it could be groupings like that, right? Where a developer, for example, who is collaborating with us might be interested in all of these combinations and running them on his software, but we might not be interested in that individually on our own, maybe.
Yeah, it would have been good to do this before the... Yeah, it's configuring. In the meantime, I can also show you the same test actually running on our system. So we have 2 nodes where we have CVMFS already mounted. And I can just launch the test suite. So here I made a configuration file. That's the only change I made, right? I made a configuration file for our system. Have a look at that. So it's Snellius, and I've made one for this test partition where we have CVMFS mounted. It has AMD processors with 28 cores. You can also specify the number of sockets. That is something that you care about. You don't have to. Kind of up to you. But if tests would use this, determine, for example, the number of MPI ranks you want on node, then it needs to be there. Another thing that you typically need to change is like, how do you access this partition, right? The partition name, do you need to pass any additional flags to get access to that? If you have different host names, the host name will be used by Reframe to automatically detect which system in the configuration file should I select, because you can have a configuration file that covers 10 different systems in a single configuration file based on host names. Okay, I should take the configuration for Snellius. I think those are the most common changes. It's not. So to launch it, I launch Reframe with this configuration file. The check path is basically the location where all of these tests are located. Tags can be used to run a subset of tests. The thing that I can do first is just list whatever tests it would generate from the Python file that specifies the GrowMax test. And it's a long list, right? It says I created 96 tests. The reason for that is that Reframe takes combinations of whatever you specify. So you can parameterize and say, okay, Reframe, I want to run at different scales, right? That's a parameter. So I want to create this test for 1, 2, 4, and 8 nodes, for example. Then I might have 3 different GrowMax modules, and I want to create a test for each. Reframe by default takes all of the combinations of those parameters and generates that as tests. That's why you end up with a big number. And then if we just select a subset, so we can use tagging. I can say, okay, in CI, I only want to run the single node tests. I only want to run 1 out of the 6 test cases that we have in there. I actually have a single node tag as well. And the -r says, okay, just run this and give me a performance. This will take a while. What you already see here is it skipped 2 tests because it generated 2 GPU tests and it found out, hey, the configuration file that you specified, it doesn't specify any GPU devices. That is something we made ourselves. So we created a hook that checks, is there a device specified for this partition? Is that device called GPU? If not, I'll skip the test. All right, so that's on our system. Back to this one. Go from the start. With me, if you, I'll create a new directory. And I will actually not use the reframe from the compat layer. We could, in theory, but it's a little bit older. And actually, this HPC test library that reframe created itself, that only got available in version 3.10 or something. By now, they have updated it a bit. So I'll just take the latest reframe version, install that in the virtual environment. Oh yeah, I need a Python here. Go. Play virtual env now. Go. All right. For the Python, just create the virtual environment. So this you can actually also do on your own home system, right? You can give it a try, just install this virtual environment. If you go through the same steps, create a configuration file that fits your system, Gromex test should run. So it would be a nice check if people can actually give that a try, and if not, report back to the PR like what is going on. Yeah, it doesn't like the copy of. Doesn't like the copy of anything. Well, I was told last time to use.
One question while this is loading. One of the inputs that applications need often to do benchmarking, to do runs, is a dataset input file.
Yeah.
Any thoughts on that?
Good point. Yeah, I mean that's tricky. I mean, then you either have to. So this actually downloads an input file from the web as part of the test. So that is one way to do it. You can also tell Reframe. You can specify a resource directory, so you could pre-download whatever you need to run the test suite. So that is something we could do, like make a script that just pre-downloads everything you need to run the full test suite, and then point the Reframe resource dir to that directory. Then you only need to do it
Are we
once.
within EESSI sort of like willing to host a bunch of those data sets over CVMFS to make sure, because I know from experience that A, the download tends to fail when you need it, and B, those downloads are such a significant size that you don't always sort of like want to put the burden on the actual supplier of that data. And we have like a very nice distribution system in our hands here.
Yeah, I'm not sure how well like Reframe works for distributed data sets. I don't.
Well, Reframe shouldn't do it.
CVMFS. Sorry, yeah.
It tends to do it really well. Atlas uses it and stuff like that.
So then it would definitely be an option. Yeah, I mean, if we can redistribute the stuff, that is then the condition, of course.
I have permission of the owner of the dataset for explicit permission.
Yeah, so then, I mean, that's the only thing we then need to check in addition.
Sure.
But yeah, why not? I think it would be a good idea.
Cool.
Yeah.
Yeah, and the other one is especially if you go towards performance numbers, it would be really interesting to be able to, within the Reframe tests, also put there some reference numbers. So far, Reframe has not been able to do that.
No, so I guess this is one way to go, right? So the traditional way in Reframe is you hard code the reference and then it checks, okay, am I within 5% of that or something? That's difficult for generic systems, but indeed a solution could be that you say, I just preview the result on your system and I give you a certain number of references, like, hey, on this architecture, 10 nodes, I don't know, 1280 cores, we get this performance, right? Similar system with InfiniBand, we get a different performance. Just so that as a user, you have some kind of context. That will be one option. But then it's on the user to check, hey, does my performance make sense in the context of these references?
Yeah, or at least point to, like, this is the layout of the system that is comparable. So this is sort of like the ballpark.
Yeah, could be that you detect like what is the closest system to your architecture, and then just print that number. Yeah, for sure.
So one thing we discussed at some point was keeping like a website or like a record of these kinds of performance tests, right, that people can reference against.
we are going to maintain sort of like the easy test definitions based on the software that is being delivered. I think we should maintain it in there and sort of like make it visible on the website or some kind of abstraction. That's nice, but don't try to store, well, let me rephrase that. Try to store that kind of data inside of the test so that it is usable from a code perspective, instead of just trying to represent it in a human read fashion. Sure, yeah, exactly, yeah.
All right, by now we've installed everything. I've copied one of these reframe settings files, and there's a couple of things we need to change here. First thing, because this one was designed for the hackathon, based on Magic Castle, CITC. I'll just call this thing. Oh, I call it CITC. Host names. It's not very important, right? We can tell it which system it is, and then it bypasses the automatic system detection. So I'll just leave it as it is now. Scheduler, it can only be Slurm if Slurm has accounting. Otherwise, it has to be SQ. And of course, the access has to change. Specify what kind of node I want in ITC cluster. And this one, 64 core AMD machine. And I need to change this to 64, right? And now I've basically specified this is the cluster that I have that I want to test on, right? And then again, I can use, just the list command to check, can I list the tests? The answer is yes. Yep, there we are. It found 4 tests, 2 for GPU, 2 for CPU. Well, it skips the first. Now we actually run them. Yep, it skips the first 2, starts to run the other 2. So if I would look in the queue, we should now see Reframe has submitted 2 jobs, and it will monitor these jobs. Once the output file is there, it will track the sanity pattern and the performance pattern and see if that, well, and it will print the performance and check the sanity pattern. So this will actually take a while, because this test on these nodes, I think it takes like 5 minutes. Go back to the run our system on Snellius that has finished by now. This is basically the output that you get, right? So it tells you, okay, we ran this test on so many tasks, and this was the performance that we got. And that is, in a nutshell, the demo part. So I also included some part, like if you want to run this on your own system, but essentially it's the same steps. It's just that you need to figure out what kind of configuration file makes sense for you, right? So typically, adjust the host names, adjust the access, adjust the number. Usually you should be okay. Assuming that you have Slurm accounting, right? Otherwise you need to change this one too. Right. Yeah, to have one quick look at the GROMACS check. So the part that we made comes on top of the GROMACS check that is part of Reframe, right? So this GROMACS check that it inherits from is the Reframe test, and then we create our GROMACS EESSI check based on top of that. And we create 4 different skills. So that is how many nodes do we want this test to run on: 1, 2, 8, and 16. And these are these strings will be used to set tags for these tests, so that I can easily select I only want to run a single node once, or I want to run all of the large tests, or whatever. Reframe has support to automatically find modules based on regular expression search. So I will just search for all of the GROMACS modules I can find and create tests for each of them. Then there is a part where we set the tags, right? So also, okay, maybe we want to do a certain test for monitoring, select one test for the CI. So only if it's this test case, that is one particular GROMACS input file. Then we add the tag CI so that we can select that particular. And here's a little bit, so I didn't write down the hooks, but this is how we call the hooks. So right after the test has been created, so that's why we see 4 tests, right? We saw 2 GPU tests and 2 CPU tests. So the GPU tests do get created, but then this hook checks, are there any GPUs here? If not, skip it. The second hook, tries to make a sensible amount of tasks. So it just checks how many cores do you have, and in this case, it just launches one task, one MPI rank per core. For hybrid tests, you could do something more clever where you say ranks to match the number of sockets or the number of NUMA domains or whatever you think is most sensible for your application. So yeah, summarizing, we have tags to select which test we want to run. We have hooks to make sure that it only runs on hardware that can actually run this test. We use some generic hooks to set the execution behavior, how many ranks, how many threads we create. And the performance is currently reported, but is not checked against the reference. And that's sort of the status where we are.
Questions in the room or online?
For me, as a reference, how does this compare to packages in Easy Build? Are there also, let's say, tests being performed there, or are people asked to test the software and provide some kind of reference?
So Reframe itself does usually, well, they do sanity checks. I mean, Kenneth knows this way better than I do, but it depends a little bit on what is specified in the EESSI config, right? You can specify a sanity check command, so then it will really try to run something. It can also run test suites, so typically it does the make test command or something like that. If, for example, PyTorch has an extensive test suite that takes, I don't know, 3-4 hours to run, it will actually run that. So it will build PyTorch first and then run the entire test suite, see what works and what doesn't work.
So basically, what you want to test in EESSI, you also want to test in EESSI config, and vice versa. Is that correct, or?
Well, I mean, it's one of the things we need to think about. Like, if we already test part of it during the build, right? Because that's what EESSI build does. We don't need to retest that part as part of the EESSI test suite.
Yes.
But usually these are like the test suites that come with, for example, PyTorch. Yeah, they really test, how do you call this? Like individual functionality of, you know, they call one function at a time and then check, does that work out? They don't tend to run stuff at scale, for example. So if that's something you're interested in, definitely have to do that in the.
Okay.
The big difference is there anything that EasyBuild runs as a part of the installation is on the build node. But what we definitely also want to do is, even as a part of ingesting software into EESSI, is the build is done on the build node in our build container, which is Debian. We want to then right after be able to test that in a CentOS 7 container and just see if there's something utterly broken, because at that point we really don't want to ingest it. And that's probably, yeah, it's better to do that without EasyBuild, because EasyBuild is not built for that.
Yeah, basically then you check, you know, if software was compiled and it accidentally picked something up from the build host, right? You would notice this if you then try to run the test on a different OS.
So you actually, let's say, doing a more inclusive test with, for instance, the compatibility layer, and see if that actually works on a different host.
Yeah.
So okay. Good. Thanks.
That's also why we have these different levels, like smoke tests, functional tests, performance tests, scaling tests. We're not going to run a scaling test before ingesting something into the repository, but we're going to run a smoke test. Because if the smoke tests are broken, it just doesn't make sense to test anything else or to do them. That's why we have these levels. And there was a question in here as well in Slack, maybe more of a comment by Erica. The record of a performance test will also be useful for users that have to decide which kind of architecture or system parameters to use. So thinking of the cloud and deciding which parameters you're going to run on your Mac script. So if we start sharing performance numbers, people can also start making decisions based on that.
Yes, although you have to realize that making a test generic and making that test get the most out of your systems are two things that don't always go together, right? No. So if we do something generic and say, I'm gonna run this test with one rank per NUMA node, that might not be the best way to run it on your system, right? Maybe your system performs better with one rank per socket, whatever, if there's a difference between sockets and NUMA. we're not going to test all of that, right? We're just going to, like, for us, it's enough to run this in a particular way and then see, does that kind of match the expectation on similar systems? It doesn't necessarily need to be the optimal.
Yeah, so we're not testing the system performance, we're testing the software.
Yes.
That's maybe a difference.
Yeah.
I think it's important that we make that clear to people as well, because you get in trouble for publishing performance numbers, right? With various people, with vendors and things like that, right? Especially because now you
so we
can
need a
compare
big
systems,
disclaimer,
right? And so you have to be very careful about how we do that.
Yeah.
Just a comment on that. So the performance number is just indicative. Like they need not, as he said, they need not be the best numbers, right? And then they're just ballpark numbers, just for us to know that the software works well on that system.
And we can still see regressions, right? Even if it's not the best way to schedule the thing, you can still see a regression. And you can still compare, you know, does it do something funny on this system that it's not doing on another system?
Yeah, so I just think it's important that we make it, wherever we publish data, we make it clear that this is not intended, what for the purpose it's intended for, right? Somebody have raised their hand over here? No?
Now that you're back on the other side of the room.
So one thing I've been wondering, if we, like we mentioned yesterday, if we open this up to the community and let people contribute or propose software to be added into EESSI, probably want to get tests for that as well. How much of a hurdle is that going to be for people if the test has to be in reframe?
Yeah, that's tricky.
No,
that's for sure more difficult.
Not that many people are familiar with reframe. I mean, we can do training and good documentation and stuff like this.
Yeah.
But it's Python, but it's also not really Python. It's a very weird way of programming stuff.
No, and you need to understand, like, you know, what is the pipeline that reframe goes to in a test, right?
So
you need
there's
to
a
know
lot
about
of-
these different stages, initialization, setup, etc. And it's not easy to write a proper reframe.
Do you
test.
think it could make sense that we come up with a way that people can give us a shell script that takes some input from whatever, and that whatever could be reframed, that just steers the shell script, which runs the test? And the added benefit of that would be that it's very trivial to just run a particular test manually without even having to use reframe. You can just run a script. Would that work? Does that combination make sense at all?
Yeah, I'm wondering, like, how you then integrate this in, for example, your CI, right? Then is this shell script going to talk to a scheduler, and so how? I mean, it should work on any system, right? That might be problematic. Reframe has the advantage of having a configuration file, so I can tell it what my system looks like. Just have a shell script, program all of the intelligence in there to check how many cores do I have, how many sockets do I. Yeah.
To be honest, so two things there. I have the mic. I have the mic. I'm allowed to talk now. First of all, I would say that setting up this infrastructure is definitely complicated, and that's okay because we're solving a hard problem here. If you look at sort of like the amount of software, if we assume that we're going to build all the EESSI build software, 2,500 packages, how many of those codes are really sort of like MPI aware and sort of like performance sensitive? Let's assume that's going to be 100 packages, of which are well used in the environment and like are where it's really relevant that we are concise of that. With about 100 packages that are often used, the problem isn't that big anymore.
Like,
so I would say
we can make reframe tests.
we
for
can
100
make
packages.
and it's relevant to do it right.
Yeah.
So I would say let's make the investment first for those 100 packages, do it really, really good. And only once we are at that step, by then probably reframe has advanced as well, making it easier, make the abstraction layer a little bit better. And only then sort of like look what we can broader extent.
Yeah, makes sense to me. Yeah, we're way over time. We should should move on to the next speaker. Thanks, everyone.